Hello and welcome to another episode of Modular in a Week. And now things are getting interesting, at least I think so. Today we are making VCLFOs, voltage controlled LFOs. So now we can control the control signal or control the controllers, and that controls whatever we choose. This one is also built around the 13700. Which we also used to make the 13700 VCA. So as I said in that episode, it's a very versatile chip and you can use it for a lot of modules in a modular synthesizer, for example. This one is a beast to make, so this one is going to take the rest of today. It took 3 hours to solder this, and you'll see why when we get to the schematics. So this one is, as I said, really good for making really complex patterns, evolving textures and stuff like that. And as I'll probably show you more times during this episode, the different things that you can make this do. And with that, let's go into the schematics and parts list and build something. So first of all, this is a hard build. It's if we look at the components, the part count is 61, so that's by far the largest we've had. It costs probably around $15. So the 61 parts is for 2 VC-LFOs, as the 13700 can be used for 2 modules, and so this is a dual VC-LFO. So total of 6 jacks, 4 pots, the LM13700 of course, 2 PNP transistors, some op amps, and then just loads of resistors and a few caps and 1 or 2 LEDs. So of course 1 LED per VC-LFO. One of many places I go to find inspiration and stuff is synthdiy.com. So I go into tags and I was looking for VC-LFO on this site. And I only found one, the VC-LFO 5A. And that is Electronic for Music, is the one who's done this. Tom G is, as far as his name, as far as I know. He does not support this project anymore. And if we go down here to files, we find the project file, a PDF. So here's a front panel that you can use if you choose to make this exact module, and that is not what we're going to do. Here's all the parts needed, and here is the schematics. Also he did a PCB and some fixes for that PCB. So here's the schematics, and we're not going to use everything because you can see it is made up of many parts. And to be able to explain this better, we're moving over to pen and paper. So the LFO 5A, drawn by Tom G of Electronic for Music in 1999. So a long time ago. So this is one of his designs, and many of his modules, this one included, was built up of many different things. So this is one module, and in this LFO module he has a sample and hold circuit up here. That's the pink box up here. This is power, and this one right here is a staircase generator. Down here we have a noise generator. And here is the part that we are looking for, the square wave and triangle wave LFO circuit, that it is voltage controllable. And if you watch in the PDF you can follow along if you can't really see what I'm pointing at. The important thing is the pink lines here. So we are not going to make the noise and the staircase and the sample and hold. So all of that goes away. So what is left is this circuit here. And the dotted line down here is for a wave shaper to make a ramp waveform as well. And I did skip this one. I had it lined out like this because if there was space and time, I would have done this. It does require a MOSFET, which I didn't have at home, so that's why I left it out as well. And there was no more space on my Vero board. So that's the LFO circuit, and this one worked, but I didn't get the range and the parameters I wanted with the input over here. So there's an input trim pot, which is still there, the init CV, and then we had a rate knob, and that was it. So and I had a problem that it was getting stuck in the top and bottom positions. So I wanted an offset, and I could have just added an offset here. I didn't. Instead, I found this circuit in a forum post that was linking to one of their files that they have, a big file repository, and unfortunately I couldn't find out who built this. But it's a simple offset / scalar circuit, and this one had what I wanted. So I wanted a more gain on the CV input, which this one gives, and also I wanted offset. So that is the two knobs. The CV amount, rate is the gain, and bias is the offset. So I had different names for those. And so this one, the output of this one, that's on this circuit here. If you can see from this side that this one is not that good fixed to the board. That was because I ran out of space, so I just had to cram that in there. But I added this afterwards when I wasn't satisfied with the CV input. So that's why these two pots go down here, and then those white cables over here go up and into the first op amp here. So probably a few too many op amps in this, because the output from the offset scalar there is connected to the pin 2 of the TL072 down here. And of course, this is, I need to say that the left side is one VC-LFO and the right side is one VC-LFO, so I'm using a TL072 here, the left side to one and the right side to another. So I'm doubling this circuit as well. So that is good to have in mind. Because he is using a CA3080, I'm using a LM13700, or 600 in this case, but that's because I broke one of my LM13700, so yeah. And also, this one doesn't have an LED that shows what is happening. So then I went back to last episode's schematics of the simple LFO. And this circuit here, from the LFO out, you could add this little circuit with an op amp and an LED and some resistors to get the LFO activity. And since I didn't have any room left, that is this little circuit up here. So that's a TL072 for driving the two LEDs. That is connected to the, I believe, the triangle output. So I would get a bit the sloping of the LED, not the jagged from the square wave. And that's the whole circuit. I'll try to write this down in ECEDA as I usually do. But for now I only have this. So these three circuits put together into this Frankenstein's monster kind of thing. But it works really well. One thing, it doesn't always start. When I start the whole modular, this one doesn't start. So therefore I added a reset button right there. So I can press it to cut the power to the plus side, and then thereby getting it to turn on. I don't know why it did that. Maybe someone can explain that to me. I tried a few different things and didn't get it to work, but it's no big deal. And also you can use it in the middle of a tune, and you can just press it with something and you would end the LFO slope and start it from the beginning. Might be a cool feature. And the speed up video you see also is me building this. It took 3 hours, and it was a lot of time just me sitting around thinking of how to fix these things and doing that. But yeah, almost exactly 3 hours from beginning to end. And here is the front panel, as always done in Inkscape. SVG file 13700 dual VCLFO, and you have the two LEDs, the reset. If you don't need that, if your works better than mine, then you could remove that one. Then we have the CV amount rate knob and the bias connected to the CV in, and then we have CV triangle and CV square out. And of course, because we use a 13700, it's a dual panel. So let's discuss the features. So we have a CV amount rate and a bias, and both of these are from the scalar circuit that we added. So the original rate knob is taken away, and there's only the scalar circuit left. And this means, so this one is, as we would guess, the amount of oscillation. But the bias, so the bias is connected between minus 12 volts and plus 12 volts. So by turning it, we can get it to, we get the curve to go either more on the positive side or more on the negative side. And this also affects the how much the rate, and in a different manner. So depending on where you have the bias, this one is faster and slower, or slower and faster. So they kind of act against each other a bit, but you can get quite interesting effects out of this, and even much more so when you connect them to each other. So if we take the first LFO to CV in on the second one, and then out from that one and into the VCO. So now we have quite, if we slow this one down a bit, there, and then we need to have some. So now that this is the CV amount, how much we get from the CV in. So the more we get, and then we change the bias. So now we have very little CV amount, but bias most to the left, and then we turn this up, and then we can, so now it starts to stop at the end points, and we get these effects, which are interesting, which doesn't happen when we have the bias down most to the left. And if we have it all the way up, then it will probably get stuck here, unless we have very much CV amount. Let's see, both are max. Yeah. And then of course we can take the simple LFO from last episode, and we can control this one, and that will control everything. And as I said, really strange rhythmic patterns from time to time. And with that press on the reset button, we have our dual VC-LFO done. So now we have two LFOs, three if we are counting the AAC VCO, which by changing the capacitor with a switch that we did there in the middle episode of Modular in a Week, then we have three different kinds. And it's good to note that the AAC exponential VCO and the 13700 dual VC-LFO is very different in how they behave as a voltage controllable LFO. But so technically we have three. In the next episode it's day 5, and we'll do envelope generators, and we'll start with this one, the AR envelope attack release, which with a looping function actually can be used as an LFO. So good transition or segue into envelope generators. After posting this video, I'll post another video where I show a lot of examples of what you can do with these modulations with the VCLFO. It turned out that that was quite a long part of this video, so I think it's better to make that its own video. So if you want to know what you can do with this module that we've done today, then go check that video out. Except for that, make sure you press the like button if you did like this video, the subscribe and the bell button, and there are some more things that you can look at if you head over to Patreon and maybe consider becoming my Patreon. Who knows? Anyway, until next time, take care. Bye.